You are about to enter the courtroom of Judge Judith Scheindlin. The people are real. The cases are real. The rulings are final. This is Judge Judy.
Tractor-trailer driver Miss Wakefield and compact car driver Mr. Garcia had a vehicle crash at the intersection of Taft and Dallas Streets. Who was at fault? Find out today.
This court is now in order with today's case. I don't like to prejudge things, so let's hear what these individuals have to say, starting with Mr. Garcia.
I can tell you right now, it's all her fault, that snake. Because teaching is my passion. I woke up at 6 to head to work.
The arms of the angel fly away from this star.
I ended up nearly murdered by my coworker. I was driving down Dallas and came to a full stop
Bring the vehicle to a complete stop.
at the red light when this tractor driver over here didn't slow down and hit me.
Well, what about you?
It was a perfect morning.
1, 2, 3, My baby don't mess around because she loves me so, and this I know for sure. But does she really wanna, but can't stand to see me walk out?
I woke up to my English bulldog Rutherford and my 3-year wedded husband. It was just a lovely day.
What a lovely day!
Lovely until some random tiny car smashed into my truck. Which, by the way, carried my dog. I braked, but Garcia didn't stop at the flashing light, causing us to impact.
Let's look at who was at fault.
According to my calculations,
This is the information we've been given.
We first find the coefficient of static friction of the tire with the equation of Fs equals ms times n. We then rearrange our equation to have ms equals Fs divided by n, Fs being the static coefficient and n being newtons. We can be simplified to ms equals 100 over mg, mg being because n newtons can simplify to mass times acceleration, and acceleration can also equal gravity. We then plug in all the numbers we have, which is 100 divided by 13.15 kilograms times 9.8 meters per second squared, to give us the coefficient of the tire. We then calculate the static coefficient of the truck by finding 70% of our previous answer, which is 0.546.
To first find the acceleration of the car, we have to find the mass of the car. To do this, we set mg equal to 130, and then divide 130 by 9.8, making our mass of the car 13.27 kilograms. Then to find the acceleration of the car, we set F equal to ma, so 100 equals 13.27a, and then divide 100 by 13.7 to find an acceleration of 7.54 meters per second squared. Then to find the acceleration of the truck, we set F equal to ma, and then we therefore set F equal to mu sub s mg, setting ma over m and canceling out the masses, equivalent to mu sub s mg divided by m, once again canceling out the masses. So therefore a equals mu sub s times g, making a equal to 0.546 times 9.8. So the final acceleration of the truck is 5.35 meters per second squared.
The conservation of momentum states that the total initial momentum must equal the total final momentum, the equation being m1 times v1 initial is equal to m1 times v1 final. We use this law, since the car crash was an inelastic collision, to find the initial velocities of both vehicles. So to find the initial velocity of the truck, we use the mass of the truck times the velocity of the truck initial is equal to the mass of the truck times the velocity of the truck final, plus the mass of the car times the velocity of the car final. We're given the weight of both vehicles, so we converted that into mass by dividing by gravity, which is 9.8, and we are also given the angle at which each car followed after the collision. We found the resultant final velocity for both vehicles and multiplied that by the cosine of the given theta angle, since we were working in the x direction to find the initial velocity of the truck. So we end up with 7,119.13 kilograms times the initial velocity of the truck is equal to 7,119.13 kilograms times 10.27 cosine 7 degrees plus 1,383.46 kilograms times 11.14 cosine 53 degrees. We isolate to find the initial velocity of the truck, which is 12.507 meters per second. And we use the same law of conservation to find the initial velocity of the car, plugging in the same mass values and the resultant velocity values. However, use sine instead of cosine, given the given theta angle, since we are working in the y direction now. Isolate to find the initial velocity of the car, which is 12.783 meters per second.
So, who's at fault? Let's find out by comparing our calculations to what Mr. Garcia and Ms. Wakefield have said. Let's start off with car driver Mr. Garcia. Garcia claims to have made a full stop at the light before the intersection. However, our calculations and his statements don't seem to add up, because if he did stop before the intersection, provided that his car can only accelerate at a rate of 3 meters per second, his velocity would have only been 8.83 meters per second, not 12.783 meters per second. Thus, Mr. Garcia has proved himself wrong with his own statement and is at fault. But don't get too excited, we have more. Truck driver Miss Wakefield also dared to claim that she traveled at 6.7 meters per second and started braking just before the collision. However, her claimed initial velocity is nothing close to the 12.507 meters per second our chief physicist, Dr. Savannah, has calculated. Therefore, Miss Wakefield was also wrong. Because both Mr. Garcia and Miss Wakefield have presented inaccurate statements to this trial, both are at fault. Case dismissed.